Hey guys, I had one of my viewers reach out on one of my videos and drop me a comment. I'll place the link to the video here at the top right corner of the screen. An RCA 8X541 Cause and Effect Part 5. It was about oscillator troubleshooting and common failure points. And another use for the coil itself, it lets me sniff out the oscillator. You can see I can use a simple diode and modulate the carrier from this receiver using the local oscillator in a tuned circuit back to this receiver in close proximity. Pretty cool little trick you can use. You can see I decided on using just a little plastic coil former and wrapping the wire around numerous times. There's many online design tools to somewhat get you closer in the ballpark for inductance based on the diameter, using a little double-sided tape just to hold the magnet wire in place, and starting the winding process here. I'll shoot for the 61 turns. Not sure if I'll have that much room for the total number of windings that I need, but should get me close to the inductance of just north of 80 microhenries. So one may ask why, around 80 microhenries. We can just use a simple calculation. You can see here I'm just taking the LCR meter and reading the capacitance of my probe for my oscilloscope, and you can see on the X1 or 1X setting around 125 to 126 picofarads. And as I noted earlier, my coil former just a little shorter than what I needed, so I came in just under the calculated 81 microhenries at 74 roughly. So this will work just fine. Let's plug those numbers into the math and we can calculate the resonant frequency based on the capacitance and the known inductance. And again, the simple formula you can use, I've shared it before. We'll take the square root of 25,330. We'll divide that by the inductance in microhenries times the capacitance in picofarads, and this will give us the frequency in megahertz, so around 1.64. Let's look at the scope now. So the calculations worked out. You can see we're resonant very close to the 1.64 megahertz. That works out great for these old vintage radios where the oscillator runs on the high side of the receiver broadcast band, that being the lower part of the band or higher part of the band plus the IF frequency. Hope this video was helpful. Appreciate you reaching out, asking the question. You guys out there take care. Stay well.